Hi everyone, welcome back to my channel. My name is Arinichi, and today we will continue to create a Substrate Kitties workshop in the Substrate. In the previous video, we download the palette Kitties node. I can show you it's this file. Yeah, it's the Kitties file, and it's include the palette node and runtime, and we modify some option in the palette and runtime. So we build the palette Kitties and done it with some warning. Yeah, and today video I will continue with a unique basis, custom types and storage maps. This video you ready to dive into some pillar concepts for developing parts with a frame, and including writing a storage struct and implementing randomness trait. You can use the helper code provided below to help you complete each step. This will be the basis of the next few steps. Now I will update my palette library code. Yeah, it's the palette library. I will change this code, and along with this code we all need to import the cert. Add this to your Paris cargo tom file using the matching version as the substrate string. I will write the cert for the substrate. I will or something add cert to the cargo tom file. Yeah, I can see. How we find some solution for this? Yes, maybe in this website. Yeah, we can see the cert in the dependencies of the tom file. Okay, I will copy it and add it to the cargo tom file. So I save it. Next step, we will go to the scaffold kitty struct. A struct in the Rust is useful construct to have stored data that have things in common. For our purposes, our kitty will carry multiple properties which we can store in a single struct instead of using the separate storage items. Wow, multi-properties. This may be the if I have a cat, we have a eyes, nose, and some features of the card. Oh, this come in the handy when trying to optimize for storage reads and writes, so our runtime can perform list read writes to update multiply values. Read more about storage best practice here. We'll take a look in this. Okay, we can see something. about storage. Okay, in the previous video we read it have the structure of storage. Yeah. So what information to include? Let's first go over what information a single kitty will carry. The kitty will have the DNA. It's a hash used to identify the DNA of the kitty, which corresponds to its unique features. DNA is also used to bred new kitties and keep track of the different kitty generations. And we have the price of the kitty. This is a balance that corresponds to amount needed to buy a kitty and set by its owner. And we have a gender, a name that can be either male or female. And we have owner is a account ID designating a single owner. Sketching out the types held by our struct. Looking at the items of our struct from above, we can deduce the following types. We have unsigned 8 or the 16th for the DNA. To use the 16th byte to represent the kitty's DNA. We have a type balance of for the price. This is a custom type using the frames. We can read more in the currency trade. And have a gender for gender. This type we are going to create this. Okay, first we will need to add in our custom types for the balance of an account of before declare our struct. Now we replace the action 1 with the following snippet. And find the action 1. Now we have the action 1. Write the struct to hold the kitty information. Copy it and paste here. Okay, we have a account of and balance of. In the kitty we have some information about the DNA, the price, gender, and owner. Yeah. And we have some note. We define the balance of and the count of types and use them in the kitty. If you wonder what we first line means in words, it is define the type alias. Okay, it's the alias the count of, which is just a shorthand pointing to the associate type account ID of trait. Frame system conclude that the generic type T is required to be thought of. More about this type of syntax is covered in the Rust book. So notice how we use the derived Markov to include the various helper traits for using our struct. We need to add type info in order to give our struct access to this trait. Add this following line at the top of your palette. Okay, we will put this at the top. To right, and to right. Yes. Okay. For type gender, we will need to build our our own custom enum and helper functions. Now we write a custom type for gender. We have just created a struct that requires the custom type called gender. This type will handle an enum defining our kitty's gender. To create it, you will build out the following parts: an enum declaration which specifies male or female values, and implement a helper function for our kitty struct. Now we declare a custom enum. We have a male or female with enum gender. We have a picture. Okay. Notice to use a while macro which must precede the enum declaration. This grabs our enum in the data structures. It will need to interface with other types in our runtime. In order to use the serialize and deserialize, you will need to add the thread create in the Paris Kitties cargo term. Using the matching version as the substrate upstream. Upstream. Here we just edit in our cargo term file. You can see here. There is a version 100. Yeah, that's it. So great, we now know how to create a custom struct. But what about providing a way for a kitty struct to assign a gender value? For what we need to learn one more thing. Implement a helper function for our kitty struct. Configuring a struct is useful in order to predefine a value in our struct. For example, when setting a value in relation to what another function returns. In our case, we have a similar situation where we need to configure our kitty struct in such a way that sets gender according to the kitty's DNA. We are only be using this function when we get to creating kitties. Regardless, let us learn about how to write it now and get it out of the way. We'll create a public function called gender that returns a gender type. Add users a random function to choose between the gender enum values, and we will replace the action for with the following code. Helper function for Kitties struct. Add here. Now, whenever then gender is called inside our palette, it will return the random enum value for gender. And next, we implement on-chain randomness. If we want to be able to tell these kitties apart, we need to start giving them unique properties. In the previous step, we made use the kitty randomness, which we haven't actually defined yet. Let's get going. We will be using the randomness trait from frames to do this. It will be able to generate a random seed which will create unique kitties with as well as brand new ones. In your pose configuration trait, define a new type bound by the randomness trait. The randomness trait from the frames port requires specifying it with a parameter to replace the output and block number generates. Take a look at the documentation and the source code implementation to understand how this works. For our purposes, we want to output the function using the trait to be the break to 128-bit hash with a hasher, which will notice should already be declared at the top of your working code base. And we will replace the action find line with this code. Let's say randomness. Yeah. Randomness. Now I save it. We specify an actual type in the runtime. Given that we have added the new type in the configuration of our palette, we need to configure our runtime to set its concrete type. This could come in handy if ever we want to change the algorithm that Kitty randomness is using, without needing to modify where it's viewed inside our palette. To showcase this point, we are going to set the kitty randomness type to an instance of the frame randomness collective frame. Collective we import the randomness collective target to derive your pose configuration trait from the system trait. all you need to do is set the kitty randomness type in the runtime inside. Okay, I will copy it to runtime. Yeah, it's this one. Here we have abstract array out of the randomness generation implementation. From its interface, check out this how-to guide on implementing randomness in case you get stuck. Okay, many acknowledge to start. Yeah. Oh, generate random DNA. Generating DNA is similar to using randomness to randomly assign a gender type. The difference is that we'll be making use of the breakthrough 128 we imported in the previous part. We will also be using the extrinsic index from the frame system part in order to generate different hashes if we call this function more than once within the same block. And we go to replace the action 6 with the DNA gen. So we write remaining storage items. To easily track all of our kitties, we are going to standardize our logic to use a unique ID as a global key for our storage items. This means that a single unique key will point to our kitty object. In order for this work, we need to make sure that the ID for the new kitty is always unique. We can do this with a new storage item kitties, which will be mapping from the ID hash to the kitty object. With this object, we can easily track to collisions by simply tracking whether this storage item already contains a mapping using a particular ID. For example, we have from inside the dispatchable function we could track using the ensure the kitties edges, and then we write the note that this new ID is already exists. Our runtime needs to be made aware unique assets like currency or kitties, and we have ownership of those assets like account IDs. This will be handled in storage mark on a kitty owner. So to create a storage instance for the kitty struct, we'll be using the storage map. A hash map provides to us by friend. Here what the Kitties storage item look like. We have a pallet storage and gather, and we have the type of the end map, storage map with the end map. We have hash, have the size 64 content. Breaking it down, we declare a storage type and assign a storage map that takes the 264 content and 264 restock hashing algorithm. A key of the type is T hash, and value of type is kitty T. The Kitties owner storage item is similar except that we'll be using bound backed to keep track of some maximum number of the kitties we'll configured in the runtime src lib. Well, in the runtime, hope you can see. Now it's my turn. Copy two code snippets above to replace the line action 7. Before we can track our palette compilers, we need to add new the masktd owner in the config trade, which is palette times the type similar to the kitty randomness in the previous step. Replace the action 9 with this. We copy this, go to the action 7, copy this, and that's one. Have a kitties and kitties owner. Okay, we done the finally we define the masktd owner type in the runtime. This is the same pattern as a follow-up for the currency and kitty randomness except we'll be adding the fixed unsigned 30 to using the parameter types macro. Now we have this macro. In the runtime. We have one here. I think we can find the runtime. Copy this. And copy this. Okay. Now is a good time to check that your Kitties blockchain compliance. Now we open the Ubuntu. Wait for some minutes. Yeah, after you review with no error, we are complete this part, and we will go to the departure events and errors. So in the previous section of this tutorial, we laid down the foundation here to manage the ownership of our kitties, even though they don't vary at it yet. In this part, we are putting this foundation to use, giving our palette ability to create a kitty using the storage items we've declared. Breaking things down a little, we are running to right. We need to create a kitty, a dispatchable or publicly callable function allowing an account to mine the kitty. We have the mint function, a helper function that updates our palette storage items and performs error checks. Call it by create kitty. At last, we have the palette events using the frames palette event attribute. At the end of this part, we will check that everything complies without error and call out create kitty extrinsic using the Pocket.js Ops UI. So we have some information about this part. We can use this code base. It also uses various action items as a way to guide you through this section. So we can copy it and replace in my palette code. Okay. So we go to public and private functions. Before we dive right end, it's important to understand the palette design decisions we'll be making around coding up our Kitty palettes, minting and ownership management capabilities. As developers, we want to make sure the code we write is attractive and elegant. Oftentimes, optimizing for one optimizes for the other. The way we are going to set up our palette to optimize for both will be to break up the heavy lifting logic into private helper functions. This improves code readability and reusability too. As we'll see, we can create private functions which can be called by multiple detachable functions without compromising on security. In fact, building this way can be considered an additive security feature. Check out this how-to guide about writing using helper functions to learn more. Before jumping into the implementing this approach, let's first paint a big picture of what combining detachable and helper functions look like. Whenever create Kitty, it is a detachable function or extrinsic that tracks the origin is signed, generates a random hash with the signing account, creates a new Kitty object using a random hash, and we can call the previous mint function. Mint is a private helper function that tracks the Kitty doesn't already exist. Updates storage with the new Kitty ID for all Kitties or for the owner's account, and updates a new total Kitty count for storage and new owner's account. Deposits an event to signal that Kitty has successfully been created. Now we go to write the create Kitty detachable. A detachable in frame always follows the same structure. All the palette detachables live under the palette call macro, which requires declaring the detachables function with the empty config. Read the documentation on these frame macros to learn how they work. All we need to know here is they are a useful feature of the frame that minimizes the code required to write the palettes to properly integrated in a Substrate chain's runtime. Weights. As per requirements for the palette call described in its documentation, every detachable function must have an associated weight to it. Weights are an important part to developing with the Substrate as they provide safe words around the amount of the computation to fit in the block execution time. Substrate's weighting system forces developers to think about the computational complexity intrinsic carries before it is called. This allows a node to account for the worst case execution time, avoiding lagging the network with the intrinsic that may take longer than the specified block time. Weights are also immediately linked to the free system for any site extrinsic. Is the free system? It include the memory usage, the storage input and output, the computation, transaction and block size, and the state database size. Yeah, you can need to pay for it. At this just a tutorial, we are going to default all way to the 100 to keep things simple. Okay? Assuming you now replace the contents of the Kitties with the helper file for this section, by the action 1 to complete the beginning of the function with the live load. Now we add the weight with a fee is 100. And find the weight. Yeah. Create a kitty origin for. Okay, we can add some line. This line. And add this line. And this line. Login for. Okay. So we won't go into the debugging, but log into the console is useful tip to make sure your palette is behaving as expected. In order to use the log info, add this to palette cargo.tom file using the matching version at the Substrate upstream. Okay, we go to add the log info. Can go find the log. Here you can find the login file in the debugging. Open it in a new window. You can see the log create. Now we can see how to use the log and copy it to the cargo.com file. So the next we can write the mint function. As seen when we were to create kitty in the previous section, we will need to create mint for the writing our new unique kitty object to various storage items declared in the part 2 of this tutorial. Let's get right to it. Our mint function will take the following arguments. It includes the owner, the type is account ID. This indicates whom the kitty belongs to. The DNA of type function on side 8 and 16. This specifies the DNA of the kitty going to be mint. If none is a pass and random DNA will be generated. A gender type option when gender detail, and it will return the result with a hash or arrow. Now we can paste the following code snippet to write the main function with the action 2. Now we can write the main function here. Okay, let's go over what the above code is doing. The first thing we were doing the creating a new kitty object. Now we create the kitty object with the DNA, the price, the gender, and the owner. Yeah. And then we create the unique kitty ID using the hashing function based on the current properties of the kitties. Yeah, we have a kitty ID here. So at next we increment the count for kitties using the storage getter function. Set count for kitty. You can see the count for kitty here. And check that. Our last validation is to make sure the kitty ID does not already exist in our kitty storage map. This is to avoid any possible hash key duplication insertions. Once our check has passed, we proceed with updating our storage items by making use of the try mutate to update the kitty owner vector. Try mutate. And using the insert method provided by Substrate storage map API to store the actual kitty objects and associate it with the kitty ID. Using the put provided by storage value API to store the latest kitty count. Now we have a implement palette event. Our palette can also emit events at the end of the function. This not only reports the success of a function's execution, but also tells the upstream world that some particular state transition has happened. Frame helps us easily manage or declare our palette events using the palette event attribute. With frames marked codes, even are just enum declared like this. We have the event and some function here, such as the success about the time and day. Okay, as you can see in the both snippets, we use the attribute markup to generate deposit super deposit event. Okay, this allows us to deposit a specific event using the padding below. In order to use the event inside our palette, we need to add new associated type event inside our palette configuration trait. Additionally, just as when adding new any type to our palette config trait, we also need to define it in our runtime. So this pattern is the same as when we added the kitty randomness tied to palette configuration trait earlier in this tutorial, and has already included from the initial scaffolding of our code base. Now we can declare your palette event by replacing the action tree. We will be using the most of these events in the last section of this tutorial. For now, let's use a relevant event for every create kitty departure. Complete it by replacing the action for it with its part. Now we can find those for Now if you're building your code base from the previous part and haven't been some using Amplify for that part, you'll need to add OK property for the create kitty departure. Okay. Arrow heading frame provides us with the arrow heading system using the palette arrow, which allows us to specify arrows for our palette and use them across our palette functions. Declare all possible arrows using the provide frame Marco under palette arrow, replace line action 5 with this. Declare arrow. Okay. We'll be using this arrow once we write the interactive functions in the next section. Notice that we've already used the calf kitty overflow and exit max kitty only in our main function. Now's a good time to see if your chain can compile instead of only checking if your palette compiles. Run the following command to see if everything can build. Okay, I can copy it, save my file, copy, and run 1, 2, 3. Okay, wait for several minutes. Here I finished my building with some warning and no arrow, and this video will end at this time, and in the next video we will testing with the Potato.js app UI. Now it's all about today's video. Bye and see you again. Bye.